Hello everyone, I'm Kunal, and this talk will be focusing on the build automation part, not just the Griddle. So time and time again, I see people miss the important aspect of the project deliveries, which is the build automation, such that we can follow all the good practices, such as CI, CD, and whatnot. So the main aspect of this talk, irrespective of what technologies, what stack you are using, it is first to get you comfortable with the terminologies, the jargons that are used when you are using build tools. And second, we'll try to get you introduced to Griddle. And if the time permits, then I'll do some demo with Griddle also. So I'll start. I'm a developer at Thoughtworks. I recently wrote a book on Gradle, and I do frequently commit some code on GitHub. You can check that out. I don't want to delay on this part. I'll just start right away. What do we build? We time and time again talk about builds, but what exactly is build, right? Libraries, for example, we build libraries, right? Most of you might be building applications, but that is one more aspect, like web apps, which are directly consumable. They are deployed onto some production boxes or whatnot. We build some web services, mobile apps. We build native apps. So you can see a trend that what we are talking about is what kind of deliverable is being built, right? The key term there is what are we going to deliver, and what is my key object that is getting built. We can build command line apps. But what do we have when we are talking about builds? What is the thing that we have with us? Any answers? OK, so I'll start slow. When we are building our project, we do check out something from the version control, right? What is that? Source code, basically. So what I have is source code, and what I want is the artifact that can be consumed. And that is the key. The most important part about this is that process of converting the source code into the artifact is called build process. And we want to optimize that for time, for developer productivity, and for the efficiency in terms of the expressiveness of build, the easiness of changing the files, how team is comfortable with build, and all those things. So everything in between the source and the final artifact that goes to production. Now, production can mean different things for different kind of applications. As we saw, your native app can be deployed onto consumers. Let's say a Microsoft Word is also an application, right? And its intended use is different from a web application. And mobile applications, intended usage is really different from a web application. And the way they are deployed, the way they are published is totally different. But what commonality is they are all built. How are they released and all those, their life cycles and are all actually different, right? So we have source code. We have resources such as the help files, the README files that we may want to package. There are resources like web application templates, the help documentation, images, whatever. So there are a lot of resources that you can have and that you want to be packaged with your application. We have configuration. Now, I just want to stress on this part. What do you mean by configuration? This configuration is not your boxes configuration. What is the database username, password? What is this region's endpoint URL? No, this is not that configuration. This is the application configuration that gets packaged with your app. So build tools are really not good when you are trying to do the environment management with them. The ideal tool for that is a configuration management system. Can any show of hands for anyone who knows configuration management system? What are those? Or any example? Are you awake? Cool. Anyone heard of Chef? Cool. Puppet? Not the chef in the restaurant, not the puppet that we play. They are the softwares, right? Ansible. So those are all really the configuration management tools that you use to configure your production boxes, if at all you have. If you have a mobile application, you are not going to customize your end user's mobile, right? So then they don't make sense. But if your application is a deployed application that is getting deployed onto some servers, then those things are controlled. Like my server should be in a valid state. It should have, my dev environment should have all the URLs for dev database, whereas my QA environment has QA database access and prod, so on. So these configurations are handled and should be handled by configuration management systems which are specialized at that task. So, oh, sorry. Anyways, these tasks, like how that server is built. And there is one more methodology, like when you want to do the dev and prod parity, which is like using Docker or something like a Vagrant, so that my developer environment is exactly same as what is going to be there on production. So I'm not really talking, when I'm talking about build tools, I'm not really talking about the configuration of environments. This is the application-specific configuration, which may be anything, I mean, depending on what kind of application are we building. Oh, that has died again. Cool. I'll just proceed. There is not much to actually see on the slides. But when we called, we have our sources, we have our configurations, we have our resources. What is the term that is used to define these things? And again, this is a jargon buster. I mean, a lot of people are lost when they hear about jargons that, oh, this is called, let's say, materials. So if you're configuring a CI pipeline, or if you're configuring any other tool which refers to material, so they really mean that what are your sources? So if you are in production of a, let's say, car or anything else, what you have is material, and what you are converting it to is something, right? So what you already have is your material. Your build process converts this into something that is useful. We'll come to what it is called so also, right? So they are called, of course, materials that we already have. But usually are we self-sufficient on this aspect that if we have materials, that's all we will need for building our applications? Is it true? What else do you need for building something? And again, that is a jargon buster, which most of us know, which we depend on some things also, right? What do we depend on? External libraries is an excellent example. We depend on external libraries for our build, right? So let's say my project, I'll talk realistic terms now. I have a project that is a command line application. Now I don't want to write the command line parsing library again, or that all logic again. I want to really use some command line option parsing library and just use that. Now that library is built, maintained, released by someone else, but I need to consume that, right? So we depend on dependencies basically, right? So we usually have different dependencies. Other artifacts like libraries, which are not built by us, right? And what do we call them? Of course, dependencies. Again, this seems very basic, but when you are configuring tools and when you are using a build tool, these terms, of course, confuse a lot of people that, oh, what was material, and then what was dependency, and then what was something else that I'll come to. Then who downloads the dependencies for us? Because dependencies are there, and I need to have them, right? Or what I have with me is my sources, but I need something else or someone else who would assist and download that op-parse library for me, let's say, or any other library that I want. So I need some kind of mechanism which I can tell to that, dude, please get this thing for me, and it will get it for me, right? And provide it into my class path or any place. So we, time and time again, use such systems at our OS level, right? Has anyone used native apps like Brew or apt-get if you're on Ubuntu, or Yum if you're on Red Hat, something? So you use package managers. They are the same thing, right? They get some dependencies for you. One more important thing that they do, which is behind the scenes, which at times we don't realize until something breaks, is they manage transitive dependencies. Now, this transitive dependency is the term which means that I, as a library, depend on something else also. So when you fetch me, I will take my baggage along with me. I just can't come without that, or I won't run without that, right? So those are called transitive dependencies. And this is the major point of problem in apps which have multiple libraries as dependencies, and all libraries depend on conflicting library versions, right? So there are techniques to solve them, of course. Then we have language libraries, and for fetching them, we have different kinds of mechanism. Again, being language agnostic here, NPM is one such mechanism. How many of you have heard NPM? Most of you, right? So what is it called? Node Package Manager, right? If I'm not mistaken, that bundler and RubyGems is another way of getting the dependencies from the internet, from somewhere, right? I'm not talking about that term again. So far we have just covered that what we build from, that is our materials, and what we depend on is our dependencies. And who fetches the dependencies for us is called package manager. So things like bundler, RubyGems, Bower you might have seen for fetching the front-end dependencies, right? If you're doing Haskell or Python, you must have used Cabal, pip. If you are using Java, you might have used Maven, Ivy. How many of you have used Ivy, actually? Cool. So Ivy is a tool that sits on top of Ant, actually, and enables you to download dependencies, right? Maven is a build tool, but it has the dependency management in itself. Lot of languages don't have this concept. They have a dependency manager as a separate thing, and a build tool. That really is not a build tool. For me, that is a task runner, which just runs some tasks for you, right? So these are, like if you're on JVM, and how many of you are working on JVM right now? Or JVM-based apps? So what are the rest working on? I mean, Ruby, how many? Cool. JavaScript? Cool. What else? I don't think Python? Cool. So rest, I am assuming they are working on something. Let's not discuss about what they're working on right now, but you will encounter some kind of package manager in whatever language you are working on, right? And that will download the dependencies for you. So whenever you're switching, because being a polyglot developer, you will have to figure out the parallels in different languages and different ecosystems, right? So in Java, if you are not familiar with Java, Java usually does not have a concept of different package manager. Usually they are along with the build tool. Whereas in other languages, it is mostly a different thing, and a build tool is a different thing, right? So where can we, now we talk that someone like a package manager gets the dependencies for us, right? Where does it get the dependencies from? Great. Internet, it goes to internet, it finds something. Now there is some magic there, right? How a tool can figure out where this artifact is located, or this thing is located. Let's not call it artifact. Where this thing is located, which I depend on. This must be some, so let's say if I ask you that find the answer of this question on Stack Overflow, you easily know that I have to find on Stack Overflow. But if I told you something that you don't know where it will be found, so there is no way for you to figure out where it will be, right? So I'll give you an example. Let's say I, as a company, develop something which is not open source, and I can't just release it on internet, right? But I want within my organization, which is let's say 20,000 people, right? They can't share the same source code. I need to release something to someone, and they should be able to consume it. What are the options that I have? So far, we discussed two things, right? Either we can go to internet, which is public most of the time, or we can do a local repository, something like that I built, and then I used it again, right? What is intermediary? Can we do something that is intermediate? So, anyone? Great. So artifact repositories, Nexus, they are the example of your own repository management tools, which let you host repositories within your campus, or within your intranet, or within your private cloud, whatever you want to call that. But they are not really exposed to the outside world, but your company can access it just like as if it was on internet, right? So these tools really help you. And what are these artifact and all these Artifactory? Sorry, Artifactory is a tool's name, okay? So don't get confused with anything else. So usually we get, for Java, we usually get artifacts from Maven Central. That is de facto. I mean, most of the time, artifacts are published on Maven Central, but that is not the only place. Lot of time, at least I usually prefer JCenter or Bintray. They are relatively faster, they call it that way, and they are easier to publish your artifacts too also, right? So I'll anyways go to next thing. So another option is like corporate Artifactory or Nexus that we install. Again, if you are developing JavaScript, you can get artifacts from NPM. Now NPM is also hosted somewhere, right? Someone is hosting that. If you're developing Ruby apps, Ruby gems are hosted somewhere. And your application, let's say bundler, knows where to get that from, either implicitly, or you have to explicitly specify the Git URL or GitHub URL so that it fetches artifact from. For scripting languages, it is relatively easy to take things from Git repository because they don't have to compile them, right? A script can be directly sourced from a Git repository. A Java source is really not that useful for me because I can't readily consume that. So usually Java or Scala or any compiled language will need to be compiled and a jar kind of artifact is produced so that I can consume that. So within different languages, this concept still remains the same, that there is one kind of repository. So dependencies come from repositories, actually. So every language or every ecosystem has their own concept of repository. Now, don't limit repository to languages. Your Debian also has a repository, right? Your Brew also has a repository or a metadata, which tells that where to fetch that artifact from, right? So Yum repositories are there, or for Ubuntu, you can add additional repositories, PPA or whatever. So there are different kinds of repositories, and things are fetched from there. And every repository has a format to it. Your artifacts should be listed down in that format so that your repository manager or the tool that you are going to use knows how or which version is being asked for. How would it know? I mean, it just can't know by a file name, right? That which one is the latest version. We could do stupid versioning and all those things. We should follow semantic versioning although, but others will follow that there is no guarantee of it, right? So the repository ensures that whatever artifact is uploaded onto that maintains a format. So Maven repositories will have one format, right? You will have to have a pom.xml. No matter what, whether you use Maven as a build tool or not, that is irrelevant. If you have to publish something onto Maven repository, you need to have a pom.xml, which tells about the coordinates. Now, this coordinate term is very specific to Maven, but it tells about coordinates, that what is your group ID, what is your artifact ID, and what is your version. And that helps them locate something unique, right? JavaScript, on the other hand, does not have, or Ruby gems don't have concept of group ID, and which causes squatting problem, right? Because if I created a gem called Hello World, now no one else in the world can create the gem with the same name, right? So what I think is having a group kind of system is better. Even on GitHub, your projects are prepended with your username, right? So that automatically creates a namespace. So again, dependencies come from repository. Different repositories have their own format. Wow, this is most important topic I wanted to discuss. Does anyone know about the recent issue that happened with the NPM thing? Anyone? Show of hands. Cool. What happened?
So the developer removed 9 lines of code, which eventually led a number of sites to be, almost crashing.
Exactly.
Including Facebook.
Yeah.
So basically, it was pulling some artifacts from some location, so he just committed or deleted it.
Exactly. So we talk about the immutability of code usually, that your code and the application should be immutable. That concept should be thoroughly applied onto repositories. Why it is important? Because let's say if I have to take common ground, let's say log4j or SLF4j kind of library everyone must have used at least once in their life, right? So log4j is published into Maven Central. Tomorrow, let's say I was the author of that library, and I decided that I remove that library from Maven Central. Now what happens? All the projects that were depending on that library would start failing. And that's what exactly happened with leftpad. It was the library name, right? Leftpad. So it was just to pad a string with spaces. And such a simple library that developer removed from NPM, and it caused crashing of Facebook Node.js itself. So Node.js builds were crashing itself. So it brought havoc onto the Node.js ecosystem. So ideally, it should be immutable. And luckily enough, Maven or Maven repositories are usually immutable. At least bintray and jcenter are. Bintray you can still remove, jcenter you cannot. So a lot of people do think that Maven Central is the only Maven repository. And that is a misconception. Okay, you can host Maven repository anywhere, including your own premises, your own machine, or the Nexus or Artifactory kind of thing that we talked about. So Maven repository is nothing but a format. And Maven Central is one such repository from which people can fetch their artifacts. but it is not the only Maven repository, right? So Maven, people do confuse when I talk about Gradle, and then I talk about we have to fetch the artifacts from Maven repository. Then they think about it, is it some kind of integration with Maven? No, it is not. Maven repository is a format. I can just use a curl command and download artifacts from Maven repository. So I don't need a Maven tool on my client to download anything. And same holds true for most of the other repositories as well. So till this point, is any confusion around the repositories and the terms that I used? I take silence as no. Cool. Then what do we do with the built artifacts? Deploy, exactly. And, sorry? Tag, you won't tag the artifact. You will tag your source code, actually, right? But fair, we do tag our source code when we do our release, right? What else can we do with the built artifact? Exactly. We deployed it to servers. We publish it as a library. I can publish my code as a library so that others can consume. So usually you develop either applications or usually you develop some libraries, which are nothing but people will use that. It on itself is not an application, right? It is just a library. So I can publish it as a library. I can publish it to app stores. If I'm developing a mobile app, I'll publish it to app stores. So the way I can publish is different. But essentially, I will do something with the built artifact. And that doing is either usually called publishing or deploying. If you are deploying just to source, your servers, then it is called deploying. But otherwise, it is called publishing. Sorry. Where do we publish? If it is not an app server kind of thing, I mean, I'm not deploying it onto web servers or app servers. Where do I publish? I publish it back to repositories, like Maven Central, or like Ruby Gems, or like NPM. Now, the distinction is, let's say I'm a bank, and I don't want a single line of code of my company to go outside my premises, right? So the repository from which I consume the artifacts is different from the repository to which I publish artifacts. It does not ever have to be same. Its format can be same. I am consuming from Maven repository and I'm publishing to a Maven repository which is local. But I can consume from Maven Central and publish it to my own local repository, right? So hence, it is again repeated term that where do you publish to? And you usually publish to, again, repositories. Now, one very important point, although I said that you usually just deploy applications, a good practice is to publish the application into your repository also. Why? Let's think about the scenario when, as you said, that we do tagging, right? We do tag so that I can recreate the build later in the future, right? Let's say I broke something and I just want to go back. One option is I have the tagged version, I take it out, I check it out from the version control, I build it back, and I deploy it again, which can be slower option depending on how much time does your build take, right? The better option would be that whatever am I building and whatever is a production ready thing, I should publish it to a local repository which is hosted internally. I don't want to host my application onto Maven Central, of course, right? Because it is a business sensitive application. But I will still want to host it onto any Maven local repository and consume it from there. It does not have to be Maven. It can be published to a Yum repository and be deployed as a Linux artifact. It can be deployed as a service. It can be deployed as anything. My point is not that consume from Maven, publish to Maven. My point is consume from a repository and produced artifact published back to a repository. And from there, do the deployment, not the other way around. Don't deploy directly. So that, and also tag it. So you know that this tag was deployed on this date, and if I ever want to do it again, I don't have to build it again. I just know that this artifact was deployed, right? So the correctness and the reproducibility is the very important part of any build tool, that I should be able to recreate the same build byte by byte same. I should not have any difference if I build it twice. If I check out an artifact from Git, let's say, and if I build the same tag, I should be having the same jar or var or whatever kind of file that I'm producing, right? Yeah, shit. So it can be public, it can be private, but it has to be published, basically, right? whatever we build and whatever we consume are both called artifacts, right? So I am publishing an artifact, I am consuming an artifact, okay? So we, time and time again, we hear this term that is called artifact. Artifact does mean nothing apart from the jar or the war file or the APK or whatever is your domain. Within that, what the artifact is being produced or was produced by someone else, right? Artifact could have been produced well before you started your project, and it could have been published to a repository. So artifact is the key that we want to consume, we want to produce. So what does a build tool do? Build tool compiles source code. Let's do a question answers here, right? What does a build tool do? Can you think about something that what is the responsibility of build tool? I would not say that's correct thing to do. I am usually in a position of that. Build tool should not deal with your repositories, ideally. Apart from tagging, let's say version, automatically tagging or bumping up the version automatically, it should not check out the source code automatically. What else can it do? It's a good thing that it is not shown here. So what else can it do? Apart from compile is very obvious thing. What else? Great. Create the distributable or create a distributable file or create the artifact again, right? What else? Running the tests, automated test, ideally, right? Not the manual test. It can't run that, right? But automated tests in the form of unit test, integration tests, your end-to-end test, functional test, performance test, whatever. So those kind of tests should be run ideally by a build tool with your build process. So my artifact does not get published without running those tests, right? It usually forms a chain of operation, ideally, that do this, then do that, then do that, then do that. And my Maven publish cannot happen until all tests pass, which guarantees that the artifact that is getting produced is correct. Cool. It manages dependencies, especially in case of Java, that the transitive dependencies that I talked about, right? That version conflicts and all those resolution strategies, it should provide that. It can run application locally. It's a web application, I want to test it locally. It's an Android application, I want to simulate it or emulate it, whatever you want to call it. So that has to be done by someone, right? And usually you will do my Griddle run, Griddle deploy, Griddle whatever, right? So, and all those commands should be your build tool command, whether you're using Ant, Maven, Rake, whatever. It can additionally run static analysis. Anyone knows what is static analysis of code? The reports like, cool. The reports that how much, the quality of code, like Sonar or all, whatever things that you have. Sorry? For example? Okay, yeah. It produces different types of reports, like code coverage report, quality reports, PMD, check style, and whatnot. I'm not going to details of Java-specific things. It can run database migrations. It can run web asset optimizations, right? At times, you have to compile your JavaScript files into one single file. Compile the Sass files into one single CSS file. Optimize the images for web. Create sprite or whatever. So, yeah, one thing that we discussed, like distributed binaries that are getting created by build tools, that is one of the primary responsibility. You ideally want to create jar, war, whatever. Publish artifacts to your Maven, Ruby gems, whatever, but it should be one command, not 10 things I have to do step by step. It should be the build tool who does the 10 things directly. It can generate documentation, tag releases in version control, deploy application to servers, and a lot more. So I just want to have a quick poll. Now everyone has to show their hands, right? If no, then I'm assuming the answer is no. Does everyone's project here have a build script? Cool, great. How do you manage dependencies if not Java? I mean, if you are using Maven, then fine. If you are using Ant, then still that question remains. How do you manage dependencies? I'll just the other way around. How many of you check in the jar files into your source control? Good, no one. We are in utopia then, good. Or at least in the right direction. Never, never, ever check in your artifacts into version control. Yeah. Yeah. Yes. So ideally, the best option is to host internal repositories for that, like Artifactory or anything, which can proxy your calls to the NPM repository, right? So your company can audit who is taking what module. So with NPM, it is very easy that I can publish a malicious module which can do harm to my company, right? And then just consume that module in the production app. Hence, companies usually don't want to do that. But if they want, all they want is they should have a auditability that, okay, what are getting consumed, and they can do a check. So ideally, proxy, set up a proxy, ask your company to do that using any kind of repository management tools. NPM also has a hosted option ideally, but if you don't want to go that, you can do it yourself also, right? But proxy it. The answer is to proxy it. Don't check in the into source control anything. No, but then everyone has to know what all projects are getting built, because auditing will have to happen at the source, not everyone's machine individually, right? So if you are doing a proxy, they can just check the proxy that what is getting into our company, right? So which makes their job very easy. Okay, I am assuming managing dependency was not a big problem. Now, how many steps does it take to publish or deploy artifact after checking out project from version control repository? How many say one? Great, great. 2 steps? 3? N. Cool. So if 1 or 2 steps will be required to publish something because you don't want to check in your username, passwords, and all. So someone has to check out a project and then some passwords file into your home root, whatever location, and then do that. But it should not be, never ever be more than 2 steps, ideally. 1 step to run the build and publish command, whatever, and 1 to check out the other files from other repository, which is more secure, right? So how many of you check in hard-coded paths into your application? So good. If no one, then that's great. Always check in relative paths only. Because if I check out your project on some different machine, I won't have those hard-coded paths, and then everything will screw up on my machine, right? Cool. I'll quickly move forward. Now, there was a problem. And everyone has, let's say I'm working on Java, I'll have a tendency of writing code in Java for every problem that I want to solve, right? It may be the right tool for the job, it may not be, but I have that tendency to do that in my language, right? And everyone does have the same tendency, right? And everyone reinvented the same wheel. Be it for repository, be it for build tool, be it for anything else, package managers, everything, right? The repository format. It, for a larger part, could have been the same format, but everyone does it a different way in their own languages. Now, and more build tools are also coming, right? Twitter is creating pants, Facebook is creating Buck, and Google is creating their own. Everyone is creating that, right? It's a fashion. You can check the list of build automation tools, and you will be amazed by the number of tools that are available for building softwares, right? And by the way, these are the configuration management tools. So I'll again say that, and how Griddle solves this problem, will come to that later. But the problem has been so far that everyone tries to solve that in their own language, with whatever language it is, right? Evolution of build tools, bash scripts, right? Like first day of Java was, there was no Ant or there was no Maven, right? People must have built things without those tools being present. And then they realized some problems, and then they created some tools to solve those specific problems. And very interestingly, only Java is such a language which does not have this preoccupation with my language syndrome, right? They have, although they code in Java, they have a different favorite, which is XML, right? They want to do everything in XML, so which is ridiculous, even more ridiculous. But make was there, people tried that for some time. then came Ant, and finally Maven. Good. And then came Griddle, and that guy does not want to display his Griddle's name. So, and then 2, 3 things came. Polyglot culture developed on JVM. Clojure had their own, Scala had their own, Groovy and Java had their own. But Griddle came along. So then there is a question, right? What was the problem with the bash scripts or anything like that? The problem is that they don't understand the language or they don't understand the domain that is required to be spoken by developers when they're building. You can't just say that my artifact is this. Bash will not understand it, right? A separate build tool which understands the concept of repository, what is repository, which understands the concept of dependency, will understand that, oh, this guy wants an artifact. So hence, what happened was shell scripts started becoming verbose. Everyone was reinventing the wheel that how do I fetch things using curl, someone was using wget, someone was using something else, but everyone was solving the same problem differently. Same happened with Ant, right? That, or any scripting language also, that scripting language have their own build tools, but I can't build Java using Ruby, right? It will be again verbose. I will, in every project, I will be doing the same thing, that how to manage source, how to compile it, how to package jar, how to do this thing. So that is repetitive. And same was with Ant. In fact, if you use any task runner, now I'll classify what is task runner, right? Have you used grunt or gulp? Great. And of course, a lot of you must have at least heard about it, right? Rake, make, all these are just task runners, right? Task runner, being a task runner is good. They don't have to understand how Java is compiled, how things are compiled. They just know that how to execute tasks. But what the problem is that everyone reinvents the wheel of conventions. Where will be the source located? What will be the target folder name? What will be the artifact URL? I mean, how do I decipher that URL? That, okay, this is my artifact ID, this is group ID, this is version. So everyone solved that problem again. So task runners have their own limited usability, but yeah, the same thing. Sorry, the next one. So task runners have this good thing is that you can quickly write task and their dependencies that do this after that. In Grunt, you will say do a build and then do a dist. And both steps will perform in the order that you specified. And their configurations can be done, right? So a lot of people do this thing also, right? Use IDE as the build tool. My project only works in Eclipse. How many of you are like that? No one will admit. At least I can say that. So a lot of people do this thing that, okay, it works in Eclipse. Let's decide it as a team that everyone will use Eclipse, which is not the right solution. It is not automatable. Have you ever thought about CI? How it will run on CI servers, right? Yeah? Yeah, first. No, behind you. You can use Jenkins to build it, but Jenkins will run your script, right? Where is that script? It can't understand Eclipse project or class path file maybe. I don't know. I never went to that depth. But you can't just write random task in Eclipse, right? That my jar should have this, and then do this after it is done. Send an email to everyone when it is done. You can't do that in Eclipse, right? So you will need some kind of automation tool to help you do that. Whether you want to invest that time right now or later, but it will be required. Think about teammates' preferences, right? I'm not comfortable with Eclipse. I like NetBeans. I like IntelliJ IDEA. I like VI. I like Sublime Text. I like whatever, right? We have to cater to all people's need, right? They don't need IntelliJ IDEA or they don't need Eclipse. So you just can't say that this project only works in Eclipse. There are many more reasons. I don't want to go into that right now. Why not Maven? And this can be interesting, right? That becomes an intense debate that why not Maven, right? So Maven, first thing is, did very good things initially, right? They brought a lot of innovation. They brought like dependency management, right? It was introduced by Maven, ideally, right? That at least in Java world. Ideally, you would typically download the jar, check it in the version control, and then build it. But then they introduced the concept that, oh, let's do dependency management the right way. It brought in conventions, right? that I need to have conventions that src main Java is where you will put your source code. The target is the name of the folder where the artifact will be generated, and a lot of things, right? Hence, everyone does not solve the same problem that what is the path where I need to put my source, and what is the path where it gets generated, what is the name of this task, all those things. They brought in conventions. So a lot of good things they did. But the problem is XML is verbose. Now, the solution could be different, like Clojure solves it, or like someone else solves it, basically relying on the same thing, but do something on top of that, polyglot Maven or something like that. Deviating from the standards is very, very cumbersome in Maven, at least, right? If you have to write some simple task, then you either have to find a plugin or write it yourself. Finding plugin is relatively easy because there are so many plugins available for Maven, but deviating from those plugins is again very hard. So that is the problem. But don't take my words. There is entire comparison done by good folks at Griddle, and they have done like in-depth comparison. So you can clearly see what's there and what's not there. Why this guy not working now? Sorry. So there are a lot of other differences, but I'll just jump. I'm not going into the details of Maven and Griddle right now because I'm not into that fighting mode. What I want really to do is that whatever tool you are using, whether it is a rake, make, or ant, use it the right way. That is the first motto, and then why to use Griddle. You will see the benefits then. So I'll just, between that, this switched few slides actually. Yeah. So what makes Griddle better, right? So Griddle has, yeah. Oh, sorry. Cool. So what makes Griddle better? Griddle has, one thing that we spoke about was understanding of the terms that we are using to describe our build. And Griddle does that very nicely. It understands the concepts of understanding different types of repository, whether you are using flat file or whatever to store your dependency, it can still support that. The DSL is so powerful that you can do almost anything that you want to deviate to. Although that is not recommended way, but at least if you want, because of any organizational reason or whatever reason, it is easier to do that. Dependency resolution is much better, and you have very fine control on what gets downloaded into your project. How do you exclude something from getting downloaded? How to resolve the version conflict strategies? You can really specify strategy implementations when you want to decide about the versions. It can do a lot of automatic resolutions also, like just write a plus and it will do the latest. Maven also does that actually. It is fully configurable, extensible in a way which Maven is not, because Maven is not scriptable. Whereas in Griddle, you can easily write scripts to do things, which again, I would say don't do that as a first thing, do that as a fallback. First, find a plugin which does things for you. If you don't find any plugin, then only come back to scripting model. It is quite performant. In fact, the 2.13 now is like much more performant than Maven at even compiling the normal sources. It has got good community and plugin ecosystem. It has got proper backing from an organization whose full-time job is to maintain Griddle, right? So a company is maintaining a tool, so you can be assured that it will be maintained for a long time. So I'll just come into what is imperative and declarative, because that is the very important thing that you should expect from a build tool, right? Maven is declarative, so no doubt about that. What is imperative then? That we can specify. Actually, you are partly correct that how is what makes the imperative part, that how to download, how to do this thing, how to compile. You time and time again do that, and then wiring also you do again and again, right? That I can call clean as a build task, right? Build as a clean task. I can do the swapping. I can do a lot of stupid stuff there, right? And probably my clean does not mean what you mean by clean. My build does not mean by what you mean by clean. I can write 10 different steps within the clean task. So I can write 10 different steps within the clean task. which you can't control me, right? Because I'm imperative, I can write steps, I can write sequential statements that do this, then do that, then do that, then do that. And my clean does 10 different things. So that is what imperative is. Ant was classic example of imperative tools, where you specify each and everything as a execution thing, but being imperative, it was still not scriptable, because you can't script it. Whatever imperative logics you can provide with internal Ant, only that was supported, right? Share. Yeah, that's fine. So, who is using Griddle right now? A lot of projects, including Android, a lot of people at Netflix, LinkedIn, Twitter, a lot of places. It has huge adoption now. So, if your worry is that it is very new tool, it is not. It has been there from 2009, 10-ish. It is almost 6, 7 years old now. So, don't worry about that part. I'll quickly jump to the build model part. What makes Griddle so special is it is really a tool that exposes its internal model to you for customization. Now, what do I mean by that is, if I tell you a task. So task, if you create a task, it is nothing but a real-world Java object that you use in your regular programming. And you can customize that object by calling the methods on it, setting the properties on it. You can tweak its behavior by passing methods to it, closures to it that can run arbitrary code when that task executes. So everything is really an object. And you get to see the real objects in your build scripts. So wiring them, tweaking them, giving them additional responsibilities, very, very easy. And never ever do that by the do last kind of blocks, which I'll come to in the demo if we have. But its model is very rich. So I'm skipping the slide now. Good that this is starting, because now at least I want to show you something about Gradle. So I'll just start. Oh, great, it is there. So how do you create tasks in Gradle, right? That is the basic unit. So if you have to think about, that slide is already gone. If you have to think about domain modeling a build tool, right? You do domain modeling of other business problems, right? What are the two, three things that will come to your mind when you create the classes or the objects that will be there at the runtime? One I already told, right? Task. Other is project. So project is also an object for you. You can customize that object to your heart's content. That project will have additional methods, it can have additional properties, and a lot of other things. So you get those objects as a top class variables to your disposal, and you can configure them. I'll just show you how to create a task in Griddle. Now, that task is nothing but a factory method which creates a task named hello. Now that, and I deliberately chose the longer version rather than the short version because this is more important. You are creating a task object with Griddle. You are naming that task object as hello. So this object's name is hello. Like we create person P equal to new person. But now new person is not an option for me, so I have a factory called create person, and create person does create a person and gives me back an object. It is exactly like that. The task is nothing but a factory method to which you specify a name, and it creates a task object for you, as well as it creates that hello as a proper variable and exposes it to your build script. So now that hello can be used as a variable, like a regular Java variable, and call methods on that one. So now do last, it's a method, right? What I'm telling, when this task runs, do this at the end. I'm not going into the details of what all methods are there because there are plenty of methods, but this shows the power that whatever methods are available, I can do that, and ordering and all those things and finding out what is available is just merely reading the Java doc of this task object, and you will automatically know what all things are supported, right? The smaller way is, of course, this, when I can create a task and use that indirection operator. So this is method overloading, which is available in Groovy for selected operators. And then I can assign that do this block or run this block at the end of the task, right, when the task executes. But mind it, this is not the task's main thing. Task is something else. So I can attach any arbitrary block to any other task, and that can run when that task finishes. So whether this task was Java, like Java C task, so I can do that when Java C dot do last and print this message. So whenever Java C compiles, it will do this action when it ends, right? Similarly, there is do first and other kind of methods, right? But task is nothing but an object on which I can call methods and assign more objects or more closures for it to execute. I can create another task, say by, which again is saying I'm another task. And now I say by depends on hello. So even if I call Griddle by, the hello task will be run. Griddle makes sure that. And that is not, I again chose the notation which clearly looks like a method call. So what I'm doing is I'm calling depends on method on the task object, which is by, which is just created above. And I told it that do execute this method before you are done. Griddle, everything is plugin. So by default, Griddle does not understand how to compile Java, how to compile Scala, how to compile Groovy, how to compile C++, Android, whatever. Everything is plugin. And plugin adds concepts to Griddle that, oh, there is a concept of repository, and repository is handled like this in Java. Or Maven repositories are handled like this. But everything comes from plugin. Sources, how to handle sources also comes from plugin. So Griddle by default is a task runner. It just does task ordering out of the box. But as soon as I apply plugin, it becomes very intelligent. And that plugin brings that intelligence into Griddle, and which makes it very suitable for doing any kind of language build with Griddle. And that's why Griddle is like extensively used for C++ these days, or doing native kind of things. Android, although not being pure JVM kind of thing, it still could adapt to Griddle's things. Just want to add more conventions that SRC main web app will have now JSP files or whatever templates. I just applied the war plugin, and now my project has the tasks to run an war file or to build a war file from my project. Repositories again is a method call which is accepting that I'm depending on Maven Central. Maven, for example, already by default connects to Maven Central. For Griddle, in every build file, you have to tell where is my repository. But there are shortcuts like this, so I can tell that my repository is Maven Central, and hence use that. But I can very well write IV repositories. I can write flat file. I can, like flat dir, you can tell that, oh, go to this directory, and whatever star.jar is my library class path. So it will take that also. So within repositories block, I can put anything, and that will try to resolve using IV mechanism or Maven mechanism or flat directory. And we can, of course, add more repository resolutions. How do I specify dependencies? I can just specify dependencies like the left-hand side is the scope. If you are not able to read that towards the end, it's called compile, and I am depending on Spring Framework, for example. And you can see that also is very terse. It is not like Maven that you have to explicitly specify. You can specify explicitly, but that is not required. It is very simple syntax to specify dependencies for relevant scope if you are coming from Maven background. This is called configuration. Compile is called configuration. That compile will define what sources when I'm compiling, and what artifacts do I make it available in its class path. So it will make sure that Spring Framework is in my class path when I'm compiling my main sources. But it will also make sure that JUnit, because I have put test compile, it will make JUnit available only in the case of compilation of test classes. Running is quite simple, so let's skip that. Daemon mode is one that gives you huge performance boost. So and in Griddle 3, that is going to be default mode, but right now you have to explicitly specify daemon. You can specify in properties file in your root, but for an individual command, you can tell Griddle start daemon and stop daemon. So with daemon mode, what it does is it creates another JVM, it loads that, and it keeps that JVM as a worm. So JVM has always a cost of spinning up and like going down, and then loading class path and finding classes, resolving those, and that actually slows down JVM. JVM by itself is very fast, but you will see that a lot of JVM app, if they are small commands, they take a lot of time to just start and stop, right? So this ensures that your build, actually heavy lifting is done by the daemon and not your client application. So that Griddle builds are very, very fast. So make sure you try daemon mode when you are trying Griddle. Also, one problem with build tools was that earlier build tool should have been installed on your machine in order to build a project, right? with wrapper kind of concepts, now what you need to do is just generate the wrapper and check it in. So now whoever does not have Griddle can also run the Griddle command. And they just have to use the script. Now that, of course, is OS specific, but Griddle generates for both Windows and Linux, Mac kind of OSs. So all you need to do is just run Griddle task. Yeah, and I definitely want to read these two articles. One is the 12-factor app, and second is the Joel test. How many of you have already seen any one of these or both of these? Great. But this is excellent article for anyone to read. If you are doing software development, these two articles are must read for everyone. Cool. That's it. Thank you.